Previously, we covered the core foundations. Now, in Part 2, we tackle the forgotten jobs that made Apollo 11 fly. Part 2, the women who read the sky for Apollo 11. Orbital dispatch, MUMMA. The forgotten jobs that made Apollo 11 fly. Part 2, the women who read the sky for Apollo 11. Last episode, we looked at the people whose quiet, precise work held the Apollo 11 mission together before anyone lit a single rocket engine. Today, we're going further back, before ignition, before the countdown even locked in, to the people who decided whether the sky itself was safe to fly through. Because here's the thing, most Apollo documentaries skip entirely. NASA could not launch without a weather clearance. And that clearance depended on a chain of human beings, many of them women working as civilian meteorologists and weather officers, reading paper charts, interpreting radiosonde balloon data, and making calls over telephone lines that would directly shape one of the most consequential days in human history. The launch commit criteria for Apollo 11 was specific and non-negotiable. Cloud cover, precipitation, electrical activity, and, critically, upper atmosphere wind shear all had to fall within defined limits. Wind shear matters enormously on a Saturn V. The vehicle is over 110 meters tall, and in the seconds after liftoff, it passes through different atmospheric layers, moving at different speeds. If those layers are pulling hard in different directions, the structural loads on the rocket can exceed what the vehicle is designed to handle. To measure those upper winds, weather teams at Patrick Air Force Base launched high-altitude weather balloons, radiosondes, in the hours before ignition. The balloons climbed through the atmosphere, transmitting temperature, humidity, and wind data back to ground stations as they went. Forecasters then plotted that data by hand and checked it against the launch commit thresholds. Not a computer model, not an automated system. People, with pencils, doing the arithmetic. If the numbers were outside limits, they picked up the phone and told launch control. That was the job. Simple in description, enormous in consequence. Now move forward 8 days to the Pacific. The USS Hornet was stationed in the recovery zone, and aboard her, or feeding data to her, was a recovery force meteorologist, whose job was equally critical and equally anonymous. The splashdown coordinates for Apollo 11 were not fixed. The crew had the ability to adjust their re-entry trajectory, and the final aim point depended partly on what the weather was doing in the target area. A poor forecast over the Pacific, unexpected high seas, low visibility, or electrical storms could have complicated the recovery operation significantly. Helicopter operations, swimmer deployment, the safety of the crew in the water. All of that was contingent on someone reading the sky correctly, days in advance, from a moving ship. The meteorologist on that recovery force was not famous. They didn't appear in the press conferences, but their assessment of conditions in that stretch of ocean on 24th of July 1969 was a genuine operational dependency. What strikes me about all of this is how analog it was, and how much it relied on individual professional judgment. These weren't people working with margins for error. They were working with the actual margins. And the fact that Apollo 11 launched cleanly on 16th July, and that the crew was recovered safely 8 days later, is partly down to forecasters whose names most of us will never know. The meteorological chain was as mission-critical as any piece of hardware. It just didn't photograph as well. Next episode, Part 3, looks at the next key question in this series, another forgotten role, another group of people the history books largely passed over. If you want to keep following this series, subscribing is the straightforward way to do it. We'll see you in Part 3. That is Part 2 of the forgotten jobs that made Apollo 11 fly. In Part 3, we explore the next key question. Subscribe so you do not miss it.